Engineers increasingly need to know more about the environmental performance of the construction products used in their designs. But there is a concern that comparisons between alternative materials, products and systems are not based on comparable data. This is further compounded by conflicting claims and counterclaims by competing suppliers keen to position their offering as the preferred solution.
In this programme, we're going to try to help those who want to understand more about how the environmental performance of construction products should be calculated. So today we'll be looking at what exactly do we mean by a carbon footprint? How is a product carbon footprint calculated? And we're going to use as a case study the concrete pipe industry, whose trade association have undertaken a comprehensive review into the climate change impacts of concrete and other pipeline materials.
And joining us in the studio are Stuart Crisp from the British Precast Concrete Federation and David Riley from Anglian Water.
Hello.
Thank you very much for coming into the studio. Stuart, let me start with you. Are the supply chain keen to know more about the environmental performance of your products?
Oh, definitely. I think that the government set out their stall some time ago by saying that by 2050 we need to have an 80% reduction in greenhouse gas emissions. And that's caused the whole of industry to go into play, as it were. All sorts of new legislation, policies and practices are now being followed, which is meaning that they're asking questions of industry, saying, how do your products perform? And so what we're looking at now is an escalation of those questions being asked of us as a supplier. And from that base, we're looking at interpreting those figures and giving industry back the information that they're asking for.
And David, what about things from the perspective of a client?
Well, we are really working hard to encouraging our suppliers to measure their carbon emissions associated with the products and services that they're offering to us. The reason that we're doing that is that we want to be able to optioneer between scheme designs and identify those schemes with the lowest embodied carbon impact.
And is it difficult to make meaningful comparisons between sets of data from rival suppliers?
The science behind calculating embodied and operational carbon is in its infancy. And the data that we see is based on embodied energy. So therefore it can be. However, the actual calculation in itself is quite a valuable exercise to us because it then allows us to create and complete that optioneering exercise that we need to do.
And Stuart, you very kindly allowed us to use your industry, the concrete pipe industry, as a case study. Now, we should emphasise here, we're not talking about waging a war between concrete pipes and other forms of pipes. We're trying to come up with something here that's transferable and digestible to other engineers.
Well, yes, that's right. I think that before we even get into any debate relating to which material is in a sentencing has a particular advanced performance over another, it's really important to get down to basics. And what we really need to do is help people understand the whole process of carbon accounting so that they can make informed decisions relating to the information that they're given.
But you think concrete pipes are best?
Of course.
OK, let's have a first look at what we mean by a carbon footprint.
A carbon footprint is defined by the Carbon Trust as the total set of greenhouse gas emissions caused directly and indirectly by a product. The footprint measures the greenhouse gas emissions at each stage of the product's life, considering all 6 of the Kyoto Protocol greenhouse gases: carbon dioxide, methane, nitrous oxide, hydrofluorocarbons, perfluorocarbons and sulfur hexafluoride. A carbon footprint is measured in tonnes of carbon dioxide equivalent. And this allows the different greenhouse gases to be compared on a like-for-like basis relative to 1 unit of CO2. CO2 equivalent is calculated by multiplying the emissions of each of the 6 greenhouse gases by its 100-year global warming potential. So here, using this GWP conversion factor, we can see the global warming potential for methane, nitrous oxide, sulfur hexafluoride and HFC23 relative to carbon dioxide.
So David, a carbon footprint isn't just about CO2.
No, it's not. It's about CO2 and CO2 equivalent. And if we look at the data that's available at the moment, a lot of it is focused upon CO2, and that's because it's related back to the energy embodied in the manufacturing processing of that material. However, as time goes on, that information is improving, and we are seeing more and more transparent data coming through, and I'm sure in the future that there will be lots more information available for CO2 equivalent.
Is there that crucial difference well understood in the industry, do you think?
It's not well understood, but the situation is improving. We've had guidance in the past that's been given to us, and that guidance has been focused upon looking at CO2 in embodied carbon for the reason that the confidence level in the data associated with CO2 is far greater than CO2 equivalent. However, in the future, that again may change, and we may see more guidance coming through to measure CO2 equivalent coming through, and the awareness within the industry therefore improve.
So Stuart, do some products perform well for, say, CO2 emissions, but for other greenhouse gases, a different picture emerges?
Well, yes, to an extent. I think it's fair to say that there are many, many instances where when you have the information on CO2 alone, that will represent the vast majority of all the greenhouse gas emissions. However, there are some notable exceptions, and one particular exception are plastics, which are essentially derived from hydrocarbons, crude oil predominantly, and from that process of producing the resin that goes into the ultimately the plastic that you produce, you have an emission of methane. And as we've seen from the table you showed a few moments ago, methane has a global warming potential of 25. So therefore it doesn't take much methane to go a long way in terms of increasing the carbon footprint, the CO2 equivalent of a plastic-based material, up to something like 25% extra if you're just ignoring the impact of methane.
And what about the sources of information out there in the industry? Do they make the distinction? Are the good sources of information readily available for the engineer?
There are certainly good sources available for the engineer. There are some recognised sources for the construction industry. And it's fair to say that those data sources do often declare the fact that they are CO2 only. As David has rightly mentioned, it's become much easier to accurately and reliably give information relating to CO2 than the other greenhouse gases. However, even when these databases are reporting that they're CO2 only, it's not necessarily fully understood by those receiving the data of the differences between carbon dioxide and carbon dioxide equivalent, and therefore the implications on the decision-making process if they're not incorporating those other greenhouse gas emissions in addition to CO2.
David, is that how you would see things from the perspective of a client?
The actual data that's being used is important, but it's also, from our perspective, the actual behaviours in terms of design and the culture in the organisation to use the information that's readily available now to design and construct in a sustainable way. And therefore, we are focused upon using the most up-to-date information we can. Yes, there might be questionable data out there, but the advantages in measuring carbon as accurately as possible far outweighs ignoring the information that is available. And
as we just saw, the figures are arresting. I mean, the GW conversion factor for sulfur hexafluoride, nearly 15,000 times that of CO2. That's amazing.
It's an extraordinary number. I think that what we'd also have to bear in mind is how much is emitted, and usually you'll find that these very high global warming potential figures relate to very small amounts of emissions. So actually the overall impact on a carbon dioxide equivalent footprint can be quite small. It really just depends on the specifics of the actual emission of that substance.
Okay, let's have a look at how a product carbon footprint should be calculated.
First, carbon accounting should relate to an accepted methodology, state boundary conditions and context, and show source data, calculations and assumptions. Available resources include ISO 14040 and 44, and BSI's publicly available specification PAS 2050, and Code of Good Practice for product greenhouse gas emissions and reduction claims. PAS 2050, for example, sets out 5 basic steps to determine a product carbon footprint, from process mapping, detailing all the materials, activities and processes that contribute to each stage of the product's life cycle. Checking boundaries and prioritisation, i.e. defining which emissions will be included and excluded. Collecting data based on actual meter readings and records. Calculating the footprint, calculating the greenhouse gas emissions, the kilogram CO2 equivalent, per product unit from each source. And checking uncertainty.
Okay, let's have a look at the first stage of compiling a product carbon footprint.
Process mapping.
Now tell us about the process mapping that you undertook for your industry.
Certainly. Well, first of all, we look at a number of conditions. The first one was the cradle-to-gate process, which is essentially the manufacturing of the product. And what we have to look at here are the raw materials that go into the manufacture of the product. So in our case, it was precast concrete pipes and manholes. So we're looking at the fundamental materials that go into making concrete, so aggregates, cement, admixtures, reinforcing steel, etc. And we need to look at the impacts of bringing those materials and transporting them to the production site and all the operations of the production process itself, including any consumables, which would mean release agents, engine oil, fuels and such like. And we put all that data together to give us a number which represents the process of bringing the raw materials and the transport of those raw materials together, processing them and ultimately producing that product, having it ready at the factory gate for dispatch.
What would you say, David, about the latter stages of that process?
Well, for delivery from the factory to site, we have to make a number of assumptions, and those assumptions are based on how many deliveries they're going to be, what the distances travelled are, what the diesel use per kilometre is likely to be. So there's a number of assumptions in that area. For operation and maintenance, the operation aspect is closely related to operational carbon accounting, and that means taking into account the grid electricity that's being used, the natural gas that's being used, fossil fuels, diesel in transport, etc. And for the embodied carbon aspect, it's taking into account the same boundaries as for a new build. So if we're maintaining an asset or refurbishing an asset, then we'll start from the beginning. So it's understanding the boundaries, it's understanding the materials, it's understanding what quantities of materials are being used.
Let's examine the second step.
Checking boundaries and prioritisation.
Stuart, what do we mean by that?
Well, what we have to do in checking our boundaries and prioritising is looking at the major impacts that are relevant to the emissions that we're measuring. So, for example, with concrete pipes, it's the cement, the reinforcing steel, for example, that we need to look at very closely. Maybe there are other areas which have a minor contribution to the total emissions. For example, within the production factor in the operations, you may well find that the amount of paper consumed during the process of running the business, or maybe the water that's consumed for washing clothes or showering of operatives and such like, is relatively minor compared to the overall contributions from these other things. So it's important that we take the major contributions, the minor ones are permissible to ignore as long as they are considered to be minor in their impact overall.
But David, a lot would depend on site-specific conditions here. For example, using our case study example, the bedding that you would use for pipes.
Yes, and this really comes down to the ability of design engineers and project teams to reduce embodied carbon emissions within that scheme and within that boundary. So, for example, they can be challenging on, are there any alternatives to using that bedding material? Can they be reusing waste on site? Can they reuse existing assets that may exist in that natural environment?
Let's take a look at that third step.
Collecting data.
Okay, Stuart, so how do you go about collecting the data?
Well, ideally you want to get first-hand data. So that means getting information from source and using appropriate conversion factors that are acknowledged and credible. That's always the best way, and you can follow recognised methodologies in order to do that. If you can't get hold of your first-hand data, then you look up secondary sources, and there's plenty of industry sources for secondary data. And that can be quite useful. However, it may be the case that some of that secondary data isn't actually following a recognised methodology. So there's a risk associated with the accuracy of some of that information if it doesn't fully comply. And then we have to go into the realms of looking at making further assumptions and ensuring that when we're making those assumptions, they are mappable, and we have the ability to look at any sensitivity based on whether they're going to influence the outputs dramatically or not.
David, reliable data is key, one would one would see in this whole exercise. What about assumptions? Because you have to keep an eye out for the assumptions that have been made in any exercise.
You do have to be very, very careful of assumptions and make sure from an audit point of view that you've tracked those through. But it's also consistency of how the data is used in terms of calculating the carbon footprint. For example, we use a carbon modelling tool where it's using the up-to-date emission factors where we can find them, but making assumptions in terms of the material quantities and material types that are being used.
Okay, let's have a look at the fourth step.
Calculating the footprint.
Okay, David, how do you go about calculating the actual footprint? This is the actual nub of the matter.
Sure. Well, DEFRA have been very good in this area, and they've actually released guidance on how to measure and report a carbon footprint. And that breaks the carbon footprint into 3 distinct scopes. Scope 1 being direct emissions of fuel oils used on site, nitrous oxide and methanes from direct emissions of processes. Scope 2 is indirect emissions, so that's the grid electricity that's used, and Scope 3 is other indirect emissions, and that can be emissions associated with the supply chain, emissions associated with chemical use, emissions associated with product use in the customer's home, and just as importantly, embodied carbon. Now, for the operational carbon emissions, the Scope 1 and Scope 2, they form the mandatory boundary of what we have to report. Scope 3, other indirect emissions, are discretionary. And in reporting the mandatory Scope 1 and Scope 2, that's simply a case of measuring the amount of natural gas that's being used or fuel oils that are being used and the grid electricity that's being used. And that can be done in a very, very accurate way because the majority of that sort of data is metered. The embodied carbon is calculated through understanding the types of materials that are being used, the quantities of those materials, and multiplying them by emission factors that are available from a number of sources, for example, the University of Bath Inventory of Carbon and Energy.
And Stuart, what were your experiences when you went through this exercise?
Well, we found it quite interesting how different materials and different analyses can have quite an impact on the numbers that tumble out. For example, we would use recycled steel in our reinforcement for concrete pipes, and that can reduce the overall carbon footprint of that element by 60, even 80%, so clearly a dramatic impact by the use of recycled steel. Another example is the cementitious binder that's used to make the concrete. Our members would be using up to 30% typically of PFA, a replacement to cement, and that also will have an effect of reducing the carbon footprint. So there's a number of factors that I was very interested to see how dramatically it can reduce the overall value. And I think it's important that when people are looking at data from databases, that they understand that there are different types of concrete, and therefore the recipe and the formulation and the materials that go into that concrete can make a dramatic difference to the actual final number that you see.
Okay, let's have a look at the 5th and final step.
Checking uncertainty.
David, what would you say about checking uncertainties?
I think it's on occasion to go back to basics, to really think about the boundaries that you're working to think about the going from cradle to as built as we do in our industry, and then thinking fundamentally about the significant materials that are used. Once you've got those significant materials in place, understanding emission factors associated with those significant materials, then you can start to validate and verify and build up the bigger picture. The uncertainties that may exist are in the raw data to some extent, but as we can only use the most up-to-date information we have, there are areas that may be questionable, but at the end of the day they will improve over time.
So as engineers, we've got to have an understanding of and a feel for the sort of figures that you're dealing with, so that you can look at data and think, that's not quite right.
Correct, yes, and that's really focusing on the significant materials. And if you focus on the significant materials, the uncertainties or the lack of confidence in some areas will appear more readily.
So Stuart, what sort of figures did you come up with for the total carbon footprint of concrete pipes?
Well, we had a range, and the numbers that we had was about 138 to 160 kilograms of carbon dioxide equivalent per tonne of product. And the reason for the range is that there are different strands within the pipelines themselves, the pipe products. For example, up to 600 millimetres diameter, precast concrete pipes tend to have no reinforcing steel, and clearly by incorporating the steel that will have an effect on the carbon footprint. But also size has a difference in many other ways as well. For example, with the larger size pipes, you'll have the same machinery moving the pipe around for transit into storage and stock manoeuvres and such like. So actually you'll have a reduction pro rata size of pipe for the larger pipes. So it's a range for a reason of variety of size and indeed the incorporation of the product.
This is a developing subject area. How do you see things developing, David?
Well, the last 5 years has been fantastic because we've seen strides taking place in terms of the guidance and the awareness behind carbon accounting. Moving forward, we've got new carbon taxes coming through, such as the carbon reduction commitment, and those carbon taxes are really driving behaviours and really driving the reduction in embodied and operational carbon because they're putting a cost behind it. The issue behind accuracy of data, I think, will become a secondary issue, because what we're finding is that competition between suppliers is growing, that in such that they are looking at their own processes. They're looking to try and reduce the embodied carbon and the operational carbon in the products and services that they offer. And as they have to report operational and embodied carbon in a more transparent way in the future, that will then further drive down the emissions associated with products and services that are being offered. So it's all positive going forward.
Stuart, you were nodding in assent there.
Absolutely, yes, I totally agree. We have the carbon reduction commitment, which is topical, it's new, it's recent, and it's focusing people's minds. We also have other things in the pipeline, no pun intended, which would further drive more recording and more understanding and accuracy of carbon footprinting. For example, at European level, we have a new standard coming through which would look at the environmental product declarations of construction materials. And that would embrace not just the global warming potential, the climate change impacts from carbon accounting, but also 13 environmental impact categories. So manufacturers will be busy measuring lots and lots of impacts relating to their production processes and their products. And that can only be good news for the supply chain, because what it means is that more accurate information measured more frequently to ensure that we properly understand the whole science of environmental product management.
Fascinating stuff, gentlemen. Many thanks, Stuart, David, for coming into the studio and introducing us to the whole subject of carbon accounting. Don't forget to take a look at the study notes that accompany this programme, where there's plenty more. However, for now, from us all in the studio, goodbye.